So the behavior of polynomial functions is kind of one of the main points of this section. And it says the degree and leading coefficient of a polynomial determine the end behavior of a function. So that means as you keep going to the right on the graph, what is the function going to do? If you keep going to the left on a graph, what is the function going to do? So if you have an odd degree and a positive leading coefficient, it will go up as you go to the right and go down as you go to the left. So it would go up as you go to the right and down as you go to the left. If it's an odd degree and a negative leading coefficient, it will go down as you go to the right and up as you go to the left. So down to the right and up to the left. Even degree, positive leading coefficient, it will go up as you go to the right and up as you go to the left. And then the last case is if it has an even degree and a negative leading coefficient, it will go down as you go to the right and down as you go to the left. So if you ever can't remember these, if you just type in numbers into 5x cubed, let's say negative 5x cubed, 5x squared, and negative 5x squared. These are kind of the four cases with the odd degree, positive leading coefficient, negative leading coefficient, even degree, positive leading coefficient, negative leading coefficient. And if you type in something like 10,000 to the very first one, you get 5e to the 12, which is a big number, so that means it's going up. If you plug in a negative 10,000, you get negative 5e to the 12, which is a really large negative number. So that's really corresponding to that behavior. So you can always kind of plug in numbers just to check. Okay, the polynomial of degree n has at most n x-intercepts. So it could have less, but at most it will have the number, whatever the number of the degree is, that many x-intercepts. And at most n minus 1 turning points. Turning points are local maxes and local mins. So really like the tops of hills or the bottom of bowls. Okay, so we're given a function and we're doing basically a complete analysis of the graph, of a lot of the behavior of it. So first of all, what is the degree of the polynomial? Well, this is a degree 3 because that is our highest power there. So at most, how many x-intercepts can this polynomial potentially have? Well, that would be 3 because it's whatever the degree is. And at most, how many turning points can this have is 2 because you take 1 away from that. So is the leading coefficient positive or negative? The leading coefficient is 1 here, so it's positive. And the degree is 3, so it's odd. So this is the positive odd case. So for the end behavior, positive odd, that is going to be up as you go to the right and down as you go to the left. So another way that we write that is if y is going up, y is going to infinity. That means going up. As x goes to infinity, that means as we go to the right. So basically two different ways of writing it. And then y goes to negative infinity, which means it's going down as x goes to negative infinity, which means as we go to the left. So you'll see it kind of written in both ways, either on the worksheets or on the homework as well. Okay, so if you graph the function, and make sure that you have your plots off. And my window, I want to do negative 3 to 3, negative 2 to 10. And if I graph it, it's going to look something like this. So how many x-intercepts does the polynomial actually have? Well, only one. How many turning points does the polynomial actually have? We have one here and one here, so that'll be 2.